Question given here is a star 2.5 times the mass of the sun. It is 2.5 times the mass of the sun and collapsed to a size of 12 kilometers, rotates with a speed of 1.2 revolutions per second. Extremely compact stars of these kind are known as neutron stars. Certain stellar objects called as pulsars belong to this category. So, will an object be placed on its equator remain stuck to its surface due to the gravity, where you can consider the mass of the sun as 2 into 10 power 30 kilograms. So, a body will get stuck at the star's surface if the centrifugal force of star is less than the gravitational force. Then the gravitational force is given by the formula Fg is equals to Gm by r square, capital M and small m by r square. So you can consider this as 6.67 into 10 power minus 11 into 5 into 10 power 30 into m. This m we need to find out. Okay, divided by 1.2 into 10 power 4 whole square. So you'll be getting around 2.31 into 10 power 12 m newtons. Okay. So the centrifugal force is given by the formula Fc, that is equals to mr omega square, where omega is equals to 2 pi v. Okay, omega is equals to 2 pi v. So mr into 2 pi v whole square. So m into r is 1.2 to 10 power 4 and this 2 pi into 1.2 whole square. So you'll be getting around 6.8 into 10 power 5 m newtons. As we can see that the gravitational force is greater than the centrifugal force, thus the body will remain at the star.